Hello everybody! In this video we will study Euler's number and one of its applications. We should consider the function f of x, which is equal to 1 plus 1 over x, all to the x power. Here's the graph of f. We said in class that as x approaches infinity, y approaches 2.7182818 ... This number has been named e, so therefore we have the following definition for e. E is the limit of f of x as x approaches infinity. It's a good idea to memorize this limit so that you recognize it in your calculus class. In this video we will explore an application of e in the financial world. Part 1. Let's talk about compounding interest once per year. Suppose you have $100 and you decide to put it into an investment account with an interest rate of 10%. And suppose that your bank will compound interest one time per year. The $100 is called your principal, P for principal. The 10% is your interest rate. Your interest rate needs to be expressed as a decimal. And n is the number of times that the bank is going to compound per year. So in this case, n equals 1. We are interested in the growth of money in our account. Now a sub 0, which is the amount of money in our account in the beginning, is equal to $100. After 1 year, we have a sub 1, which is $100 plus our interest payment, 100 times 0.10. So after 1 year we have $110 in our account. How much money do we have after 2 years? Well, we have the $110 plus another interest payment, 110 times 0.10. So we can calculate this to be $121. This process will continue. Okay, so let's talk about what's happening in general. A sub 0 is equal to our principal. After 1 year, we have our principal plus an interest payment, P times R. If we look hard, this is factorable. We can take out a P and we're left with 1 plus R. After our second year, we have the amount of money in our account after the first year plus another interest payment. Again, we can factor. If we take out a sub 1, we're left with 1 plus r. But remember, a sub 1 is equal to p times 1 plus r. So we can make a substitution. A sub 2 is equal to p times 1 plus r times 1 plus r. That means a sub 2 is equal to p times 1 plus r squared. So let's review. A sub 1 is equal to p times 1 plus r to the first. A sub 2 is equal to p times 1 plus r squared. The pattern will continue. The amount of money after the third year, the principal times 1 plus r cubed, and so on and so on. So if the bank compounds interest once per year, the amount of money in our account after t years is equal to the principal times 1 plus r to the t power. Part 2. What if the bank compounds interest more than once per year? So again, suppose you have $100. And suppose you put it into an investment account using the bank of Mr. Nursberger. This bank is an interesting bank. This bank will give you a 10% interest rate, and the bank of Mr. Nurse will compound interest 2 times per year. That means you're getting an interest payment twice per year. Okay, so your principal is 100, your interest rate is 0.10, and now n is equal to 2. We are interested to see how our money grows. The amount of money in the beginning, a sub 0, is $100. Now, after half of a year, the Bank of Mr. Nurse is going to give you an interest payment. So we'll call it A of 0.5. Now, the Bank of Mr. Nurse is not a stupid bank. We're not going to give you 10% both times. We're going to give you 5% both times. We're not just giving away money here. So after half of a year, you're going to have the $100 plus our interest payment, which is 100 times 0.05. After a half of a year, you're going to have $105. Now, after 1 year, you get another interest payment. The $105 plus interest turns out to be $110.25. You can compare this to the other bank if you want. The Bank of Mr. Nurse is a little bit better. But we should focus on what's happening in general. The amount of money in the beginning is your principal. The amount of money after half of a year is equal to the principal plus interest. Make a big note, the interest payment here is our interest rate divided by 2. Just like before, we can factor out P, and we're left with 1 plus R divided by 2 to the first. You might be recognizing our pattern already. We have A of 0.5, and we have to the first power. If we continue, we'll get the amount of money after the first year is the principal times 1 plus the rate divided by 2 squared. The amount of money after a year and a half will be the principal times 1 plus the rate divided by 2 cubed. The amount of money after 2 years will be the principal times 1 plus the rate divided by 2 all to the fourth. This pattern will continue. So if a bank decides to compound 2 times per year, the amount of money after t years will be equal to the principal times 1 plus the rate divided by 2 all to the 2t. In fact, this entire discussion generalizes. So, if a bank decides to compound interest n times per year, the amount of money after t years is equal to your principal times 1 plus the interest rate divided by n to the nt. Okay, so let's run an experiment. Let's consider that $100 that we're putting into an investment account that we're getting a 10% interest rate for. And we'll make a little chart for ourselves. In the first column we have compound, the second column we have what n equals, and in the third column we have how much money is going to be in our account after 10 years. If the bank compounds yearly, that means n is equal to 1. The amount of money after 10 years, using our formula, can be calculated to be $259.37 to the nearest cent. Suppose the bank compounds semi-annually. That means n is equal to 2. After 10 years, we'll have $263.33. Suppose the bank compounds quarterly. That means they're giving you an interest payment 4 times per year. After 10 years, it turns out we have $268.51. Suppose we find a bank that compounds monthly. That means that they're giving us a interest payment 12 times per year. After 10 years, we have $270.70. Suppose we find a bank that compounds weekly. That means they're giving us an interest payment 52 times per year. The amount of money in our account after 10 years turns out to be $271.57. Whoa, what if we find a bank that gives us an interest payment every day? That means they give us 365 payments per year. After 10 years, we'll have $271.79. Whoa, what if we find a bank that is going to give us an interest payment every minute? 525,600 payments is how many the bank will make. And so the amount of money in our account after 10 years will be $271.82. Now, it seems like as n increases, the amount of money that we are making also increases. But it also seems like there is a limit to how much money we are making. So the question is, what is happening as n approaches infinity? So, part 3, what's happening as n approaches infinity? Okay, start with our formula. Remember, the bank gives you an interest rate and they give you the number of times they are going to compound every year. So here is a true fact. If we take n and divide it by r, we will get a number. In other words, our true fact is this. There is a number x such that n is equal to r times x. And if you believe this true fact, then you must believe everything that follows. Look at your formula and make a substitution. N is equal to r times x. N right here is equal to r times x. Next, note that there's a cancellation. The r's cancel. So we have 1 over x, and then we can use the commutative property here, x times r times t. Now, use the properties of exponents. These two lines are the same because we have power to a power, so we can distribute the exponents. So now, to answer the question, as n approaches infinity, in other words, as n gets very, very big, x will also approach infinity. If n gets very big, then x will also get very big. And as x gets very big, our function that we talked about in the very beginning approaches e. So we derived a formula for what is called the continuous compounding of interest. When a bank says it's continuously compounding interest, your money grows according to the following formula. The amount of money after t years is equal to your principal times e to the RT power. It's easy to remember this formula. All you have to do is remember my favorite shampoo, Pert Plus. This is a shampoo and a conditioner in one, and you can find it at your local grocery store. Okay, I hope you've enjoyed this recreational math video, and I hope it gave you some insight into 3 important formulas in the financial world. Goodbye, and have a nice day.